Before I'm going to start with this lesson about quadrilaterals, I would just like to mention that for me it's very important that you do copy all this information into your class books, because at a later stage we're going to refer to this information back and then we need to physically see it. So yes, copy it for me in your class books. Thank you. Welcome at lesson 7. This lesson is all about quadrilaterals. Now let's first see what is a quadrilateral and what are the rules, the properties of a quadrilateral. Now a quadrilateral, first of all, is a closed four-sided figure. So any kind of figure with four sides will be classified as a quadrilateral. What more about it? And the interior angles add up to 360 degrees. So there are the two properties. It must be a closed figure, must have four sides. The total interior angles add up to 360 degrees. Now you get many kinds, different kinds of quadrilaterals. Let's have a look at them now. The trapezium. How do I know that this figure I see here is a trapezium? First of all, I must remember the property of a quadrilateral. It's any kind of figure. Closed figure. It must be closed with four sides. Now, the trapezium. The property of a trapezium, only one pair. And it got to be opposite. So if I look at the sketch, one pair opposite. And that, what about it? It got to be parallel. So the symbol for parallel is that little arrow there. So if I'm going to make those two sides to be parallel, it's opposite each other and it's only one pair, not that other pair, only one pair. When I see this in a figure with that property, I know that this figure will be then the figure of a trapezium. One pair opposite will be parallel to each other. Trapezium. Now for the next quadrilateral. We call this quadrilateral the kite. Now, how do I know again that this figure is a kite? Now let's first look at the first one, the first property. Two pairs adjacent. Now what is the word adjacent means? Adjacent means that two sides are next to each other. So if I look at this side here, that side there, and this side here, we can see that they are next to each other. So that means they're adjacent. So what about it? They are equal, two pairs. So it means to be the top one. So I can say that that side and that side will have equal lengths. The next part, the second pair, is the bottom adjacent lines. So therefore, that side and that side will also then be equal in lengths. The next property, a single pair of opposite angles. Now, opposite angles means they're opposite each other. That means if I look at this angle in total, that angle must be then equal to that angle down there. And that's another property of the kite. Let's look for another one. Number 3, diagonals. Now, let's first see what is diagonals. Diagonals is a line from the corner. No, I do not refer to it as a corner. I refer to it as a vertex. So from the vertex, corner, vertex to the opposite vertex, that line then going to be referred to as a diagonal. Then I have another one, the horizontal diagonal from the vertex to the vertex. Now what about those two diagonal lines? They say they intersect each other at 90 degrees. They cutting. Intersect means they crossing, cutting each other. So therefore that angle then they got to be the 90 degrees. That angle there also to be 90 degrees. That angle there also to be 90 degrees, and then that angle there also then to be 90 degrees. And that's the third property of the kite. Let's look for the fourth one. They say the longer diagonal. Now the longer diagonal is the vertical line from the vertex, top vertex, to the bottom vertex, that vertical line. The longer diagonal bisect, cutting, crossing, cutting in this case, the corner angles. Right guys, if I look at this one here, bisect means cutting in halfies. This case, that means now I can say now that the longer one, this is this guy here, cutting that one. So it means that that angle and that angle there got to be the same. And it means also this diagonal line bisect, cutting halfies, this angle and that angle there then got to be the same. The last one, the shorter diagonal, that's the horizontal line from vertex to vertex, bisected the longer by the longer diagonal. It means that this longer diagonal cutting the shorter one in two exactly equal parts. That means that this part here, that half is on the left, must be then equal to that half is down there on the right. Now guys, these are the properties of a kite. Every time we must know all the properties of a particular quadrilateral. So at a later stage, when we go over to the calculations, we will be able to do that. So the properties, very important. Now for the next quadrilateral. This quadrilateral is referred to as the parallelogram. You can see the figure here again. It's a closed figure with four sides. But what about those sides? Let's first look at the first property of a parallelogram. Both pairs, that means both. That part, opposite. Opposite sides. One side opposite, two sides opposite. What about it? They gotta be parallel to each other. So let's start with this one. They say that this side then here, remember the symbol for parallel, and that side they got to be parallel. So opposite. What about the other opposite pair? It means that that side and that side got to be then also parallel. So here I have the two opposite pairs to be parallel. And I'm continuing. And they got to be also equal. So it means that that length and that length is the same, opposite. That also means that that length and that length also to be opposite. Let's look at another property. Opposite angles are equal. That means that that angle and that angle opposite got to be equal in size. That means there's another opposite. There's an opposite there as well. Opposite, that must be then the same in that particular case. That means there's a last one then that I can refer to. Diagonals bisect each other. Diagonals. Now what is a diagonal again? If I quickly going to add the diagonals, there, remember, it's from vertex to vertex. Let's see if I can draw it straight enough. From vertex to vertex. Yes, I'm close. Therefore, what can I say about those diagonals? They bisect. Bisect, remember, cutting each other in half. That means the half is on the left. It's going to be, so this side here and that side there going to be the same. They cutting, they bisect each other halfies. That means that this diagonal then also here must be then the same as that halfies down there. Right guys, and here I do have the properties of a parallelogram, and I have to know this again. When I see all that properties, I know that this figure then to be a parallelogram. Now for the next quadrilateral, again, figure with four sides, and it's a closed figure. This time it's a rectangle. What can I say about a rectangle? How do I know that this figure is a rectangle? Let's look at the first one. Both pairs of opposite sides are parallel and equal. Opposite, that means that side's there, those will be then parallel to each other. Let's put the symbols in. Those are parallel, and then that side, opposite that side, will be then parallel. And they are also equal in length. That means that length, that length, that length, and length is to be the same. Now the next one. Oh, here we go. The corners, the vertex angles equal 90 degrees. It means that that one, that one, that one, and that one, those corners are 90 degrees every time, and by that I so far know that it must be a rectangular. But there's one more, the diagonals. Now, yes, I remember the diagonals are from vertex to vertex. So let me see if I can get it in again. Vertex to vertex, I'm close. What can I say about that then there? I know they say diagonals are equal in length and bisect each other. They're equal in length. Yes, from vertex to vertex, they got the same length, and they're cutting each other exactly at half. So because they are the same diagonals, same length, if I cut it in half, it means then that all the sides down there diagonals must be then the same. Guys, and those are the properties of the rectangle. The next quadrilateral, the rhombus. How do I know this quadrilateral will be a rhombus? If I look at the properties of a rhombus, I see that all sides are equal. That means that that side, that side, that side, that side, they are all equal in length. The next property, opposite sides are parallel. That means that side, opposite, parallel, both of them. That one and that one, parallel. Both opposite sides are parallel. Opposite angles are equal. Now I have to be careful. That means that that angle, opposite angles are equal. That angle and that angle opposite. So the opposite angles are equal in size for the rhombus. Now the last one, second last. Diagonals bisect each other at 90 degrees. Remember a diagonal from the vertex to the opposite vertex. And what can I say about that? Where they are bisecting each other, cutting each other, half is down there, 90 degrees, 90 degrees, 90 degrees, 90 degrees angle where they are bisecting, cutting each other down there. Next one, diagonal bisect. Remember, bisect means cutting in halfies in this particular case. Very important. Bisect. Let's quickly do the diagonals. Bisect. That means that that side also is that side down there. Is that side also bisecting, cutting each other down there, the diagonals. Now the last one, bisect the corners, angles. Bisect means cutting half. Now I have to be careful. That means that this angle and that angle must be the same. But remember, the opposite angles are also to be the same. So if I cut that one in half, it means that this one then here also will be the same value. That means that this one then down here, if I can just try to make a star, I'll try to put a star in there. That one and that one to be the same. Opposite, the same situation. That one and that one to be the same. Guys, there are many properties inside a rhombus that I got to remember. And remember, if I see that properties, I do know that that is a rhombus. Now for the last quadrilateral we're going to deal with in grade 8 is the square, maybe the most common one used, the square. So let's see the properties of a square. How do I recognize that this figure will be a square? Now let's look at the properties. All four sides are equal in length. That means that all of them must be the same length. So I'm going to refer to that side, that side, and that side, all the sides to be equal in length. And more, opposite sides are parallel. So therefore, that one, opposite sides, parallel. That one down there, and that one the opposite to be parallel to each other. Furthermore, the corners at the vertex, all of them got to be 90 degrees. Remember the symbol for the 90 degrees. All corners at the vertices are 90 degrees. The next one, diagonals are equal and bisect each other. Diagonals, let's quickly see again. The diagonal, yes, go from vertex to vertex. What can I say about the diagonals again down here? The diagonals are equal and bisecting each other. In other words, the lengths first, they are the same. And now they're bisecting each other. It means they're cutting each other half. Because the lengths are the same, it means in cutting half, all the parts of the diagonal will be then the same length. Also, the next one is and at 90 degrees. It means that that angle 90 degrees, 90 degrees, 90 degrees, and also that one there to be 90 degrees. The next one I would like to, diagonals bisect the corner angles. Now remember previously we have said that all the angles are the same to be 90 degrees. So if the diagonals bisecting the angles, it means that all of them will be the same. So that angle and that angle must be the same because they are bisect. But because all angles are the same, that one, cutting half is bisecting. So all my angles bisecting will be then the same. Guys, here we do have all the quadrilaterals we're going to deal with. It is very, very important for me that you do copy all this work, all these facts about every quadrilateral for me in your class book, so that when we continue later on with calculations, when we look at the figure of the calculation, we must be able to know the properties so that we can do the calculations of that particular question. So I'm asking you nicely, please put it in your exercise book so that we can use it into the next lesson. Thank you very much, guys. Today this will be all because it's a lot of work to copy into your books. Till the next time when we're going to continue with calculations concerning this. Have fun. Till later.